Hi friends, it's Amy here. In this lesson, your students are going to be using partial sums to add. All right, we're dealing with, if you're in Florida, the same standard number sense and operations 2, the same benchmark 2.1, where we're adding and subtracting multi-digit whole numbers, including using the standard algorithm, which we get to in the next lesson with procedural fluency. So we have this problem here. Eli and Mila break apart the add-ins by place value to add 438 plus 155. How can each student show their work in a different way? Well, we can decompose what they're learning about today. It's decomposed in the add-ins by place values to find partial sums. Okay, and then they'll add the partial sums to find the sum. This is one of those topics that you are going to see videos all over social medias and TikTok where you have parents going, why are we doing it this way? It's so much easier to do the old method. We're doing this way because we're building the why. When I used to work with my daughter with math, she used to always want to know why. Why are we carrying a 1? Why are we borrowing? We're building the why. We're getting to the algorithm because the algorithm is more efficient. We are going to get there. But the students, through working with partial sums, can understand why the algorithm it works. So number one, it's important for us to spend that time building the understanding of why the algorithm works. Number two, it's building number sense, because the reality is a lot of times as adults, we do mental math and we either pull out our calculator, but we're not going to sit down and write out an algorithm. So it's sometimes easy for us just to mentally add by place value. So that's my soapbox for today of why we're using partial sums. I promise we're getting to the algorithm next. All right, so first of all, method one is to write the add-ins in a row. So we're adding these two numbers. We break them apart by place value. So we would add 400 plus 100. We add our hundreds. That gives us 500. We add our tens, 30 plus 50. That gives us 80. And then we add our ones. 8 plus 5 gives us 13. These are our partial products. Partial sums. Oops, I gave you a glimpse. We are going to do partial products also. These are partial sums. Okay, they're a part of a sum. So we add them together to get the total sum. 500 plus 80 plus 13 gives us 593. Now we can also stack the add-ins. Okay, so we would have 438 plus 155. All right, so we start by adding the hundreds. We are starting on the left because it doesn't matter when we're finding partial sums. We could start whichever number we want to. So we're starting on the left. We have 400 plus 100, which gives us 500. Then our tens, 30 plus 50 is going to give us 80. And then our ones, 8 plus 5 is going to give us 13. Notice how we're going to make that connection to carrying the one, regrouping. We're not going to call it carrying the one, by the way. We're going to call it regrouping. To regrouping when we get to the algorithm in 2 lessons where we are regrouping. So we get 593 for that one. Okay, so here's some types of problems that your students will have. They'll have some where maybe they're asked to do this by the row. So they would here be adding 300 plus 400 to get 700. 20 plus 70 would give them 90, and then 8 plus 1 would give 9. So we would have 700 plus 90 plus 9. So we get 799. Okay, I agree. I know what you're thinking. Way easier just to add them up. We're going to get there, I promise. But they're going to understand it when we get there, hopefully. So, all right, now here we would start 500 plus 200 is 700. And then we don't have any tens here, so 0 tens plus 90 gives us 90. And then 6 plus 4 gives us 10. All right, 90 and 10 is 100, plus 700 is 800. All right, so now they'll have a couple problems like this. I have some different ones on the students, so in case you need to look at a couple different examples. So we have Lawson uses partial sums to add, look at his work to determine which two numbers were in his original equation. Okay, so here are his partial sums. So we can see the two numbers here. The first number is 110 and 6, 116. The second number is the 630 and 5, 635. So don't make that harder than it is, especially on this one, because honestly, I could see myself, if I hadn't really understood partial sums and was working with my daughter back in the day, I could see myself going, okay, well, let's take 593 and subtract 255, find out what the missing number is. No, we're building and working on that understanding of partial sums. So how can we get 500 here? Well, we would have 200 plus 300. So 200 plus 300. I use 200 because we've got the 200 there. How did I get 80 here? Well, I have 50. So what would I add to 50 to get 80? I'd need another 30. I've got 13 here. I have 5 up here. What would I add to 5 to get 13? I would add 8. So the other number is going to be 338. We haven't done subtracting yet with borrowing or regrouping, as we're going to call it. So don't try to work it that way and explain that to your student. It's just going to get them confused because we're not there yet. All right, my friends, I hope that you all enjoy that lesson. We'll see you in the next one.